With Jetpack Compose, you describe your UI in Kotlin as functions. No more XML needed. Let's dive deeper into these functions and how you can build UI with them. Let's see how we can build a single choice question screen of Jet Survey, one of our Compose samples. Earlier, we saw that a single answer in the survey can be written in Compose as a function containing a row with an image, text, and a radio button. To create a UI component in Compose, we must annotate a function with the @composable annotation. This annotation tells the Compose compiler that this function is intended to convert data into UI, so an answer into UI. Functions with this annotation are also called composable functions, or composables for short. These functions are the building blocks of UI in Compose. It's quick and easy to add this annotation, encouraging you to break your UI into a library of reusable elements. For example, if we wanted to implement a list of possible answers to select from, we can define a new function called single choice question that takes in a list of answers, and then call the survey answer function that we have just defined. This composable function accepts parameters, which allows it to be configured by the app's logic. In this case, it accepts a list of possible answers so that it can display these options to the UI. This function doesn't return anything, but instead, it emits UI. Here, it emits the column layout composable function that's part of the Compose toolkit, which arranges items vertically. Within this column, it emits a survey answer composable function for each answer. Composables are also immutable. You can't hold a reference to them, like holding a reference to a single answer, and later update its contents. You need to pass any and all information as parameters when you call it. Notice that since this function is in Kotlin, we can use the full Kotlin syntax and control flow to produce our UI. Here, we're using for each to iterate through each answer, and call survey answer to display them. If we want to conditionally display something else, it's as simple as using an if statement. No view.visibility equals gone or invisible needed. You just call the composable if it needs to be displayed. This function is also fast and free of side effects. It must behave the same way when called multiple times with the same argument, and it shouldn't modify properties or global variables. We say that functions with this property are idempotent. This property is necessary for all composable functions so that UI can be emitted correctly when functions are re-invoked with new values. Notice that the parameters provided to the function entirely control the UI. This is what we mean by transforming state into UI. The logic in the function will guarantee that the UI can never get out of sync. If the list of answers changes, then a new UI is generated from the new list of answers by executing this function again and redrawing the UI if necessary. This is called recomposition. Recomposition happens when a composable is re-invoked with different function parameters, but it can also happen when internal state in the function changes. For example, say the survey answer composable accepts a parameter if the answer is selected or not. Initially, no answer is selected. In the view world, interacting by tapping on one of the answer UI elements would visually toggle it. But in Compose, since we passed false to all survey answer composables, all answers would remain unselected even when tapped. We need to make the composable recompose whenever the user interacts with the UI. To do that, we need a variable that holds the selected answer. But this isn't enough. We also need to be able to tell Compose that when this variable changes, recomposition should happen as well. To do that, we need to wrap the answer in a mutable state object. A mutable state is an observable type that is integrated within the Compose runtime. Any changes to the state will automatically schedule a recomposition for any composable functions that read it. To create a mutable state, we can call the mutable state of method. Since no answer will be selected initially, we initialize this to null. We also need to update the value of isSelected to compare the current answer to the selected answer. Since selected answer is of type mutable state, we have to use the value property to get the selected answer. When this value changes, Compose will automatically re-execute the survey answer composable so that the selected answer is highlighted. Creating a state object also requires that it be called within a call to remember. This guarantees that the value is remembered and not reset when the composable recomposes. With what we have now, while the UI survives recomposition, it won't survive configuration changes. To remember values across config changes, we can use remember savable. Right now, the type of the variable is a mutable state. But we can use Kotlin's delegated property syntax by using the by keyword. Doing so changes the type of our variable to an optional answer. This syntax is nice as we can work directly with the value of the underlying state. No more calls to the value property on a mutable state object. With our newly introduced state, we can pass a lambda function for the onAnswerSelected parameter so we can perform an action when the user makes a selection. In the definition of this lambda, we can set the value of selected answer to the new one. If you recall from the previous videos, events are the mechanism for how state is updated in Compose. Here, the event onAnswerSelected would be invoked when the user interacts by tapping an answer. The Compose runtime automatically keeps track of where state reads occur so that it can intelligently recompose composables that depend on that state. As a result, you don't need to explicitly observe state or manually update the UI. There are some other behavioral properties of composable functions you should be aware of. Because of these behaviors, it's important that your composable functions are side effect free and behave the same when called multiple times with the same argument. First, composable functions can execute in any order. Looking at the code for a composable, you might assume that the code runs in order, but this isn't necessarily true. Compose can recognize that some UI elements are higher priority than others, so those elements might be drawn first. Say, for example, you have code that draws 3 screens in a tab layout. You might assume that the start screen is executed first. However, these executions can happen in any order. Composable functions can also run in parallel. This lets Compose take advantage of multiple cores, which improves the rendering performance of a screen. In this code snippet, the code runs side effect free and transforms the input list to UI. But if the function writes to a local variable, such as in the snippet, this code is no longer considered side effect free and may result in odd behaviors in your UI. Recomposition skips as much as possible. Compose does its best to recompose only portions of the UI that need to be updated. If a composable doesn't use the state that triggered recomposition, then it will be skipped. In this snippet, if the name string changes, the header and footer composables will not be re-executed since it doesn't depend on that state. Recomposition is optimistic. This means that Compose expects to finish recomposition before the parameters change again. If a parameter does change before recomposition finishes, Compose might cancel the recomposition and restart it with a new parameter. Lastly, composable functions might run frequently. This might be the case if your composable function contains an animation that needs to be executed for every frame. This is why it's important to make sure your composable functions are fast to avoid drop frames. We covered a lot, so let's do a quick summary. You can create composable functions by using the @composable annotation. It's quick and easy to create composables, encouraging you to break your UI into a library of reusable components. Composables can and should accept parameters to configure their behavior. Mutable state, remember, and remember savable can be used to store a component state and have Compose automatically track and recompose changes. And composables should be side effect free. We also learned about some interesting properties of composable functions. Composables can execute in any order, run in parallel, be skipped, and run frequently. The Compose Toolkit provides a lot of foundational and powerful composables that help you build beautiful apps. That's what we'll cover next. If you want to jump ahead, check out the links in the description below. Otherwise, make sure to hit subscribe so you don't miss the next one. Stay tuned.